Imagine you are running a small furniture workshop. You have a limited amount of wood and only a few hours of labor each day. You want to make chairs and tables to get the highest profit possible. But how do you decide exactly how many of each to build? This is the heart of linear programming. It is a mathematical superpower that helps us make the best decisions when resources are tight. This video was generated on Fluent.help, where you can create your own personalized educational videos in just minutes. Before we solve big problems, we must master the basics. Linear inequalities. Think of an equation like x equals 3 as a single point on a line. But an inequality like x is greater than 3 is an entire region. It is an infinite collection of possibilities. On a number line, we show this by shading everything to the right of 3. Notice the open circle at 3? That is because x cannot be exactly 3. It must be strictly larger. Now, here is a warning. This is where many students lose marks. When you multiply or divide an inequality by a negative number, the sign must flip. Look at this. Negative 2x is less than or equal to 10. To solve for x, we divide by negative 2. Because we used a negative number, the less than sign flips to become greater than or equal to. So, x is greater than or equal to negative 5. Why? Because multiplying by a negative reverses the order of numbers on the line. Don't forget it. When we move to two variables, x and y, the solution isn't just part of a line anymore. It's a half plane. Let's graph 2x plus 3y is less than or equal to 12. First, we treat it like an equation to draw the boundary line. If x is 0, y is 4. If y is 0, x is 6. We connect these points with a solid line because of the equal to part of the sign. To know which side to shade, we use a test point, like 0, 0. Since 0 is less than 12, we shade the side containing the origin. In linear programming, we usually have multiple constraints at once. This creates what we call the feasible region. It is the only area where all our rules are satisfied. Watch as we add constraints. X must be positive, y must be positive, and our previous line. The area where these three overlap is a triangle. Any point inside this triangle is a valid choice for our workshop. Any point outside? Impossible. It would break one of our rules. Now for the goal, the objective function. This is a formula, usually called z, that represents what we want to maximize, like profit. Let's say z equals 5x plus 4y. This formula creates a family of parallel lines. As we increase the profit z, the line slides further away from the origin. Our job is to slide this line as far as possible while still touching the feasible region. Look closely. Where does it touch the region for the very last time? Did you see that? The line touched the region last at a corner. This leads us to the corner point theorem. It states that the optimal solution to any linear programming problem must occur at one of the vertices of the feasible region. This is a massive shortcut. Instead of checking every single point in the shaded area, we only need to check the corners. Let's test our three corners, 0, 0, 6, 0, and 0, 4. Let's do the math. At 0, 0, the profit is 0. Not very helpful. At 0, 4, we have 5 times 0 plus 4 times 4, which is 16. But look at 6, 0. 5 times 6 plus 4 times 0 equals 30. 30 is our maximum profit. So, the best decision for our workshop is to make 6 units of the first item and 0 of the second. By following these 4 steps, graph, find the region, identify corners, and evaluate, you can solve any standard LPP. But wait, math isn't always so perfectly behaved. Sometimes you might run into special cases. What if your constraints never overlap? This is called infeasibility. There is no solution because the rules are impossible to satisfy together. Or what if the objective function is perfectly parallel to one of the constraint lines? In that case, every point on that entire edge is an optimal solution. You have infinite choices. Knowing these edge cases prevents you from getting stuck when the math looks weird. Finally, there is the unbounded case. This happens when your feasible region isn't closed in. It goes off to infinity. If you are trying to maximize profit in an open region, your profit could theoretically be infinite. In the real world, this usually means you forgot a constraint. After all, no workshop has infinite wood. Always check if your region is bounded before you start celebrating your infinite riches. From manufacturing to logistics and even planning a healthy diet on a budget, linear programming is everywhere. You have learned how to graph inequalities, find the feasible region, and use the corner point method to find the best possible answer. Here is a challenge for you. If you have a square feasible region with corners at 0, 0, 4, 0, 4, 4, and 0, 4, and your profit is 3x plus 2y, which corner is the winner? Think about it and keep practicing. Don't forget to subscribe for more math deep dives and visit fluent.help to create your own amazing videos just like this one. See you in the next lesson.